This is scientist Charles. He explained the relation between volume and absolute temperature. These are the topics we are going to learn in this Charles law. The relation between absolute temperature and centigrade temperature is explained by this formula. Capital T is equal to small t plus 273.15. Approximately, sometimes we have to write only 273. Small t means Celsius temperature, capital T means absolute temperature. So, statement of Charles law. At constant pressure, the fixed amount of an ideal gas, its volume is directly proportional to its temperature. So, as per the Charles law, we have to write the mathematical expression in this way. V is directly proportional to capital T. V is directly proportional to capital T. So here, when you remove the proportional symbol at constant what? Pressure and fixed mass. So now when you remove the proportional symbol, you will get one constant K into T. Now V is equal to V divided by T is equal to K. So we can explain the Charles law with respect to this equation also. That is V by T is equal to K. At constant pressure, the fixed mass of a gas, volume and temperature ratio is equal to one constant, is also known as Charles law. In case of two different conditions, V1 by T1 is equal to K and V2 by T2, V2 by T2 also is equal to K. V2 by T2 is equal to K. So here, based upon these two equations, we can write the final equation with respect to two different conditions. V1 by T1 is equal to V2 by T2. So two equations we have got in Charles law. Now, what is the graphical representation for this? So V is equal to some constant K into T. It is looks like a Y is equal to mx. So when Y is equal to mx, the Charles law we can represent in this manner. So this is x-axis and this is y-axis. X variable I am taking as V. V. And here I am taking T. T versus V. When T increases, V also increases. The straight line, it will go through the origin. Temperature increases at this particular temperature. At this particular temperature, what is the volume? This is the volume. At this particular temperature, what is the volume? This is the volume. It means when temperature increases, volume increases. That's the reason both are directly proportional to each other. So this is about the graphical representation, and this is about Charles law. This Charles law we can explain with respect to the Celsius temperature also. With respect to Celsius temperature, the Charles law we can write in this way. V is equal to V naught plus V naught by 273 into small t. This is Charles law we can express with respect to Celsius temperature. V is equal to V naught plus V naught by 273 into T. The volume of a gas at particular T temperature, Small t means this is a degree centigrade. Volume of a gas at Celsius temperature is equal to V naught, original volume, plus original volume by 273 into T. So when temperature increases either 1 degree centigrade or 2 degree centigrade or 273 degree centigrade, temperature increases, this much amount of volume will be added to the original volume. This much volume is added to the original volume. This is the original volume of a gas. For example, I am taking a container. This is one vessel. This is the original volume of the gas, V naught. This is the original volume. Okay. This original volume V naught, when make it into 273 parts. 1, 2, 3. Like that 273 parts are there. You can assume like that. Out of 273 part, this is one part. This one part is considered as 1 by 273. Whom out of its original volume. Its original volume is V naught. How much it is, I don't know. Out of that, this part is 1 by 273. Right? When you increase the temperature, 1 degree centigrade temperature, when you increase 1 degree centigrade temperature, how much amount will be added to the original volume? This is the original volume. So this much amount should be added. When you increase 2 degree centigrade temperature, how much volume should be added to the original volume? V naught is equal to V naught plus 1 by, instead of 1, 2 degree means you have to write 2. 2 by 273 into V naught. Why I have written 2 by 2 degree? 1 degree means 1 by 273 volume should be added. One more 1 degree means 1 by 273 part should be added. 1 by 273 plus 1 by 273 what ma? 2 by 273 of its original volume. It means 2 portions. 2 degree centigrade means 2 portions of volume will be increases. See here, I am increasing 2 degree centigrade. 2 degree centigrade means 1 by 273 will be increases. This is one part and this is the another part, like that. When you increase like that, how many times you are increasing, how many centigrade temperatures you are increasing, that much amount of volume increases. Why? When temperature is directly proportional to the volume. Temperature increases, volume increases. How much increases? 1 by 273 of its original volume. Okay, original volume, when you are taking this much, here this much volume, you have to divide into 273. When sometimes you can take the original volume, this much is the original volume. So this much original volume, V naught, you can make it into 273 parts. So here 1 by 273 small, but here 1 by 273 somewhat big. It is based upon its original volume. In its original volume, how much increases? For every 1 degree centigrade, 1 by 273 part of volume increases. When you decrease, how much decreases? 1 by 273 part of volume will be decreases. Okay, this is about clear explanation regarding Charles' law. Okay, next we have to see about what is absolute zero and absolute temperature. Absolute zero or absolute temperature means a temperature at which the volume becomes zero is known as absolute zero. A temperature at which the volume becomes zero. Once again I am writing a temperature at which volume becomes zero. Zero. So that temperature is known as is known as what? Absolute temperature. Absolute temperature. Absolute temperature. So now I am going to show you what is absolute temperature. My dear students, now only I explain you the centigrade and Kelvin scale. I am writing the Charles law with respect to centigrade. Volume V is equal to V naught plus V naught by 273 into small t, means centigrade temperature. Now I am writing, my dear students, this volume at what temperature? This temperature. So that is the reason here you have to write T. When I am writing at 0 degree centigrade, T becomes 0 degree centigrade. So what will happen? V naught plus V naught by 273 into 0. So when into 0 means entire this becomes 0. This becomes 0 means at 0 degree centigrade, at 0 degree centigrade, at 0 degree centigrade, what ma? The volume become V naught. At 0 degree centigrade, the volume is, we can written as V naught. Now, when you want to do at 1 degree centigrade, at 1 degree centigrade, what is the value will come? Again, I am substituting here, this is the equation. At 1 degree centigrade means V naught, here I am substituting 1 degree centigrade, that is equal to, tell me, V naught plus V naught by 273 here into 1. So what value come? At 1 degree centigrade, the volume become V naught plus V naught by 273. The same way, when you want to write 10 degree centigrade temperature, the volume at 10 degree centigrade, here 10 degree centigrade, what the volume? V naught plus V naught by 273 into 10. Same way I am writing at 273 degree centigrade, V naught, okay, V naught at 273 degree centigrade is equal to V naught plus V naught by 273 into 273. So what will happen, my dear students, here? The volume, this 273 is get cancelled. So the volume at 273 degree centigrade, the volume of gas is V naught plus V naught. V naught plus V naught means how much volume, Nana? 2 V naught. So it is very important point. At 273 degree centigrade, the volume of gas, should be doubled. Why? Here you are getting 2V. Any gas. At what temperature? 273 degree centigrade temperature. When you heat 273 degree centigrade temperature at any gas, that gas, when you take 2 liter at 273 degree centigrade, the gas volume become 4 liter. When you take 5 liter initially at 273 degree centigrade temperature, the gas volume become double. Now I am applying in another case. So for example, I am applying at minus temperatures. So V is minus 10 degrees centigrade. I am applying minus 10 degrees centigrade. Same formula, my dear students. V naught by, tell me, V naught plus V naught by 273 plus, here what should you apply? Minus 273 minus 273. What's answer will come? This is 273, this is 273, get cancelled. So you will get V naught minus V naught. So V naught at minus 10 degrees centigrade, V naught by 273 into minus V naught by 273. So once again I am writing this, just a minute. So V at 273, I am writing, this is minus 273 is equal to V naught plus V naught by 273. This is minus 273 temperature. 273 temperature. So this 273 and this 273 get cancelled. Now I am writing the equation V naught, this minus into plus, this should become minus V naught. At what temperature? The volume of a gas at minus 273 degrees centigrade temperature. V naught minus V naught is what, ma? 0. 0. So at what temperature? V is equal to minus 273 degrees centigrade. Entire the volume becomes 0. Entire the volume become 0. So this temperature is known as absolute temperature. Absolute temperature. Absolute temperature. So here this is about clear explanation regarding your absolute temperature. Absolute temperature means what I told you, a temperature at which volume becomes 0. That temperature is known as absolute temperature. Here the volume is becoming 0 at minus 273 degrees centigrade. So this is about the clear explanation regarding your Charles law. Now I am going to show you the slides. V is proportional to T. By removing the proportional symbol, you will getting V is equal to KT, V by T is equal to K. For comparing the same substance under the different states of condition, V1 by T1 is equal to V2 by T2. So explanation, when temperature increases, the volume also becomes increases. Here this equation is not there. Next slide. Examples statement. If the absolute temperature of a gas is doubled at constant pressure, determine the change in volume. Solution. Absolute temperature of the gas is doubled means T2 is equal to T, 2 times it is doubled. Absolute temperature means T1. Absolute temperature means T1. We have a formula V1 by T1 is equal to V2 by T2. So T1 means absolute temperature, initial temperature, that is 273. T2 means experiment, how much extent of temperature you are giving. This absolute temperature is doubled. So T1 is become, this is doubled means 273 into 2. But they are not given 273 value here. This T1 becomes 2 times is doubled. Doubled means 2 T1. T2 we are substituting T2 is equal to 2 times T1. That is the question. If absolute temperature of a gas is doubled, absolute temperature of a gas means T1 that is doubled at constant pressure, determine the change in the volume. So simply according to the law, V1 by T1 is equal to V2 by T2. Then V2 is equal to V1 T2 by T1. V1 into T1. So the volume becomes double. This is the equation. While substituting T2 is equal to 2 T1, the value get double when the temperature of gas is double. Just you have to substitute instead of T2, 2 T1. Example 2 statement. The initial and final temperature of neon is 289 Kelvin. Initial and final temperature of neon gas is 2 given. Initial temperature is T1 and final temperature is T2. Find the initial volume of the, initial volume. Initial volume means V1 you have to find out. Final volume they have given, that is V2. So we have a formula V1 by T1 is equal to V2 by T2. So based on this you have to calculate V2, write the V2 formula. V2 is equal to what will come? V1 by T1. V2 is equal to V1 by T1 into T2. When substitute the values, you will get the answer. So this is the substitution. V1 is equal to V2 T1 by T2. When you substitute 2.3 into 289 by 323, you will get the answer 2 liters. Therefore, the final volume is 2 liters. These are the two examples of numericals based on your calculations. Okay. Next one. So this I have explained you. The Celsius temperature explains the Charles law. Vt is equal to V0 plus V0 by 273 into T. So this Vt we can write in this pattern. Vt is equal to V0. I have common V0 in this case, 1 plus T by 273. So Vt is equal to V0 into, while simplifying this, 273 plus T by 273. Then Vt is equal to V0 Tt by T0. V0, this is considered as Tt. Why Tt? So we have a formula, capital T is equal to what formula? Capital T is equal to small t plus 273. So this 273 plus small t we can write as a T. So that is the reason at particular temperature, Tt. T0 means 273. T0 means absolute temperature, that is initial temperature is 273. Tt means the absolute temperature at T degree centigrade. Absolute temperature at T degree centigrade, Tt. T0 means absolute temperature only. Absolute temperature means 273. So here 273 plus T, instead of that I am writing Tt, and T0 means 273 we can represent it as T0. So based on this, Vt by V0, when V0 comes under left hand side, Vt by V0 is equal to Tt by T0. This only we can express with respect to 1, 2 numbers. So Vt means final temperature at that is V2. V0 means initial volume, that is V1. Final volume, initial volume. Final temperature T2 after experimental condition, and T1 initial temperature, that is absolute temperature. So this equation we can write in this way also. That is the reason the same equation I have given 3 different methods. V1 by T1 is equal to V2 by T2. So finally all these equations explains what V is proportional to T. So where Vt is equal to volume at T degree centigrade, V0 means initial volume at 0 degree centigrade, Tt means 273 plus T degree centigrade, T0 means 273 plus 0 degree centigrade. I explain you what is absolute zero. A temperature at which the volume becomes 0, that is known as absolute zero. That only I have written in the printed manner. For each degree changes the temperature, the volume of given mass of a gas changes by fraction of 1 by 273 of its original volume. So at 0 degree centigrade the volume becomes V0, and at 1 degree centigrade the volume becomes V0 plus V0 by 273 into 1. At 10 degree centigrade the volume becomes this much, and at minus 10 degree centigrade the volume becomes, and at the same time at 273 degree centigrade the volume becomes is, that is doubled. At minus 273 degree centigrade the volume becomes is 0. See here, these 2 points are very important. To understand these 2 points, the above equations I have given. This is the point. At 273 degree centigrade temperature, the volume becomes double. This and this cancel. This V0 plus V0 is equal to 2V0. The volume becomes double. At minus 273 degree centigrade, the volume becomes 0, because this 273 get cancelled. V0 minus V0 is equal to 0. That 0 is known as absolute 0. Now, graphical representations of Charles' law. V is directly proportional to T. It is looking like a y is equal to mx. Y is equal to mx. As per a mathematics student, y is equal to mx means you know very well about that. Always y and x indicates variable, m is the slope. So this is the slope. Okay, slope means constant, it is a tan theta. So when V here, when V volume increases, this is temperature increasing from left to right. At particular this temperature, this is the volume. At particular this temperature, this is the volume. It means when temperature increases, volume is increasing. When temperature decreases, volume decreases. One more graphical representation. All of you look at the board. This graphical representation indicates centigrade temperature. Here this graphical representation is indicating absolute temperature. Concentrate clearly. This graphical representation explains you absolute temperature versus volume. This graphical representation indicates centigrade temperature with respect to volume. So what I told you, my dear students, in the beginning introduction, we have taken one container or vessel. Always each and every gas should have a initial volume. It have a initial volume. It have a initial volume. This initial volume we are representing with V0. Each and every gas should have volume. So it have a volume. So it have a volume means that volume, if anything is starting with little amount or gas is there, that is the reason this line I started with here. This line I started with here. It is have some volume. How much volume? 22.4 liters of mole inverse. 22.4 liters of initial volume is there. That is the reason I am not started from 0. It have some volume at STP condition 22.4 liters. That is the reason the volume increased. The volume increased up to here 22.4 liter. Now hereafter onwards, when temperature increases, what will happen? Volume increases. Increasing volume. Volume increases. When temperature increases, volume increases. Temperature increases, volume increases. Right. When temperature decreases, what will happen? Volume decreases. I am decreasing the temperature, cooling. I am cooling, then the line is going move towards this side. When temperature decreases, this line is moving like this, moving like this, moving like that, and here touched. So when you see the scale here, the scale value is minus 273 degree centigrade. This is centigrade temperature, Celsius temperature. So at minus 273, you are cooling. The volume becomes 0. This is the volume. Here this much volume is there. Entire this is the volume. This volume is decreasing. This much is decreasing. Here decreasing. Here decreasing. Here decreasing. Decreasing. Finally, here the volume should be 0. The temperature at which a gaseous volume should become 0, that temperature is known as what, ma? Absolute 0. So this is called absolute 0 temperature. At minus 273 degrees centigrade, the volume of the gas becomes 0. This is indicating graph with respect to centigrade temperature while heating and as well as cooling, both heating and cooling. While you heat, the volume increases. When you cool, the volume should be decreases. So like this, the volume is decreasing. I think you understand this graph. Locating of straight line changes with the temperature in the isobar shown in the following. Whenever the graph, when you draw with respect to volume and temperature, these lines are called as isobars. This is isobar line in chemistry term. When a graph plotted between temperature and volume, whatever the graphs you are obtaining, those graphs are called as isobars. So here different volumes are there. When you observe, my dear students, different volumes. Here the initial volume is this one. See here, this is the initial volume. In another one, V0 is different. This is another gas and this is the another gas. Observe clearly, my dear students. When temperature increases volume, increases in temperature, at this temperature, the volume of the gas is this one. At this particular temperature, this is the volume. At this particular temperature, this is the volume. This is the volume. At this particular temperature, this is the volume. When temperature increases, volume increases. Temperature increases, volume increases. And when temperature increases, pressure decreases. Relation, observe carefully. Temperature increases, volume increases. This you understand easily, because when you take a closed container, one container you are taking, this is one of the gas. When you heat it, the gaseous molecules will occupy more space, hence the volume increases. Temperature increases, volume increases. Clear? When temperature decreases, this all going to be compressed. Cooling. Cooling means molecule intermolecular space will be less than it will be compressed. Compressed means what will happen? Pressure decreases. See here, temperature is directly proportional to volume and the same temperature is inversely proportional to volume. Here the P1, the pressure P1 at this particular temperature, this is the temperature T. At this temperature, this is P1. At this temperature, this is P2. At this temperature, this is P3. Which is high? P1 is high. At what temperature? At what temperature P1? At P1 temperature, at P1 pressure is always greater than P2. P2 is always greater than P3. It means temperature increases, volume increases, pressure decreases. Pressure decreases. So this explains the same thing with the different volume versus temperature while heating and cooling. Here this line is the first line at P1 temperature. Why I am giving P1? Measurable properties are volume, temperature, pressure and mass. Mass always fixed. You are not adding or we are not subtracting. So any one you should be stable. At this pressure, at P1 pressure, the relation between volume and temperature. At P1 pressure, what is the volume? This is the volume. At P2 pressure, what is the volume? This is the volume. At P3 pressure, what is the volume? This is the volume. It means at P3, the volume is increased. At P1, the volume is decreased. Limitations. Charles' law is applicable to only ideal gases. Charles' law holds good for real gases only at high temperature and low pressure. The relationship between the volume and temperature is not linear in nature at high pressures. At high pressures, the repulsive forces among the molecules are significantly increased, which cause the expansion of the volume. Real world applications we'll see one by one. Applications of Charles' law in our day-to-day life. Hot air balloons. Hot air balloons. In what way it will works? We will have seen hot air balloons flying, but has anyone wondered how it works? An air balloon consists of bag, a basket to carry passengers, and a source of heat. The heat source is usually a fuel like propane, which on burning causes the heating of the air surroundings it. When the air is heated, as per Charles' law, results expansion of air. Example, an increase in volume, and with an increase in volume, the density of the air decreases. Hence, beyond the acts in upward direction on the balloon and it flies. Tires. In the summer season, sometimes tires of vehicles gets overinflated. It is because of Charles' law. When a vehicle is left untouched for a prolonged period, as the summer season approaches, there is a rise in temperature which causes the air inside the tires to expand. Human lungs. Jogging is very difficult in colder days compared to the hotter days. The reason is simply due to low temperatures, our lungs shrink, which decreases the human lungs capacity. Pool floats. When inflated pool floats are pushed into pools,